Dr. Henrik Svensmark from Denmark, from Danish Space Research Institute. For decades you're doing research on cloud formation.
Yes.
And so together with Nir Shaviv, for many years ago, you already did research, you published your results. So what was the gist of this, the main message, the main finding in this field of cloud formation?
I mean, I think that now we have a very, very good, I would call evidence that there is a beautiful connection between changes in clouds and changes in cosmic rays, which are these particles that come from space. And they are modulated by solar activity, and the new thing is that we can actually quantify it in a beautiful way, and it is very, very consistent with all observations. And one of the main things is that people have been saying that what we are doing don't work because climate models have shown that this effect is too small, but none of these models have taken into account a special feature of cosmic rays, which is that they help the formation of what we call cloud condensation nuclei, and this is what you need in order to get a cloud. So when we include this process, we actually start getting results that fit very, very beautifully with a process that we found in 2017. It turns out to be extremely important for the survival of these aerosols, so they can actually affect clouds. And we actually now see that when we make the similar types of simulations that has been done previously, but now including this mechanism, we start getting results which are very close to what we actually observe. And one of the things I showed also was how large is the change in cloud condensation nuclei when we have a change in cosmic rays. And I showed we have found a way to extract that from the data. And this quantity, it's about 1.8%. It doesn't sound like much, yes, but it's almost 100 times larger than what you get from all the other models.
Oh, that's very interesting. So, if you compare from the traditional models and now what you now found actually empirically, so how would you say that?
Yeah, but I would say that empirically, with all the data, they are consistent, and they're all showing that there is a real and a significant effect on clouds, and this effect is changing the amount of energy that goes into the climate system. And the thing that I also mentioned is that now we can even upgrade some of these models with this mechanism, and we start getting results which are close to the observations. And this is the first time you start seeing that.
So, and how is your research, the findings you have, how are they received in the other scientific community?
That's a good question. Some of the things I'm talking about today has not been published. They are in the review process. So I haven't heard what they have, the reactions to it. But I mean, my last three papers, I got a diploma, saying that there was among the most downloaded papers. So that's happened for the last three papers. So there is an interest in this field, which is good.
Yeah. So you did over the last decades a lot of research, even at very prestigious institutions like the CERN, and of course in your institute. So how is the current research situation for you? Because I mean, you found you could actually disprove basically the importance of the current models, and now you have something which is not really supporting what was supposedly the only truth.
The thing is that, I mean, and what I also suggested in the talk was that with this new process that we have tested in one type of model, the idea is to put it into a real global model where you also have greenhouse gases and so on, because we know that there's been a significant change in the ionization from cosmic rays over the last 100 years. And so there's a long time trend in that, and that means that this process should have warmed the Earth. So it will be really interesting if you put it in together with the greenhouse gases, because it might actually say that the effect from greenhouse gases alone is much smaller than what you get from ordinary models as they are now.
Okay, that's very interesting. So what is your future plan regarding your research? What are you planning to do next?
I hope to continue my work. And then, I have some obstacles that I have to go through. I don't know if we're going to talk about that, but I hope to continue my research, and I can do a lot. I just need a little funding.
Okay, the famous,
thing,
ever-limiting factor of funds. Okay, but after basically more than 30 years, and I follow your research for many years, and this new development where okay, now you could prove that there's much more correlation or more significant impact of cosmic rays, and so this is actually really something is a groundbreaking, development after many years or not?
When I started this, I was very uncertain whether it was true or not, and I tried sort of to show that maybe it's wrong, and I would like to do it myself to show it's wrong. But over the years, everything seems to be falling into place. And we now have, we did the experiment showing that there is an effect and it works in the experimental setting. And we have all the observations that supports it, so showing that this process actually seems to be working, and now we have the modeling. So everything is going the right way. So it seems to be correct that cosmic rays can use the cloud to force the Earth's climate. And if we go on the very long time scales, which Nir has been talking about, there we see climate changes are even much larger. So, and if this process is responsible for that, it will be one of the most important climate mechanisms that exist.
Excellent. So I wish you all the best for your future research, and looking forward for your next results.
Thank you.